Back to another exam walkthrough. We're going to be doing some questions from 2022 Jan Unit 2. So here's the first one. This is an MCQ. So we have a diagram with the EMFR internal resistance, and then we have two resistors connected. The potential difference across R1 is V1, and then we have R2 as well. This entire circuit is in series, so the current is same throughout this circuit. So current is going to be same throughout. Okay, and then they ask us which expression is correct. We're going to use Kirchhoff's voltage law, or the energy conservation, which is the sum of EMF is equal to the sum of potential difference. And we're going to get this as our expression. Firstly, we have this potential difference, then plus this potential difference, which is IR2, plus the potential difference across the internal resistance, which is going to be IR as well. Okay, the current will be same throughout because it's a series circuit. And this matches option number D. Then we have the next question. It says, as temperature increases, the resistance of the negative temperature coefficient thermistor changes. We know that as the temperature will increase, the resistance is going to decrease. And the main reason for this is that the number of conduction electrons are increasing, more of them are there. And the option that matches this is B. So the answer is B. Remember, A and D are correct, but they're actually going to cause the resistance to increase. Okay, and then the reason why the resistance actually is going to decrease and not increase is because of this factor right over here. Okay, so that's all for this. Let's move on to the question number 8. This is actually a really easy question. So here I have all the graphs. This is a ohmic conductor graph. This is a filament bulb or the filament lamp graph. This is a diode graph, and this is a thermistor graph. And we can easily see that this matches diode. So this is going to be diode. This is a bit more of just a memory based question. You should just know this. Okay. And yeah, so this was the answer of all of these three. Now let's move on to a bit more of a lengthy question, which is this. Question number 17. This is a 6-marker calculation question. So the question is going to tell us that a student set up the circuit as shown. So we can see that there is a 12-volt battery, 4 ohm resistor, and we have a 3 ohm and a 2 ohm resistor that are connected in parallel. And we have to calculate the number of electrons passing through this point X. Okay. So the first thing I want to do is I want to find the total resistance of these two. So I'm going to apply the formula for the total resistance when things are in parallel, and I'm going to get the R total as. So I'm going to get that as 2 ohms. So that's going to be my answer right over there. Okay, now I'm going to do something weird here, and we're going to think of all of this as like one single component, which has a resistance of 2 ohms. So you might ask, okay, sir, why are you doing this? Well, it's kind of like a trick. Okay, it helps us to solve the question. And the main thing I'm trying to find is that how much voltage does this 2 ohm resistor take, and how much voltage will this take, the 4 ohm resistor. And using that, I can calculate the potential difference across these 2 points. And we know when things are in parallel, the potential difference will be same. Okay, so let's just define the values out first. Okay, let's find how much voltage will 4 ohm resistor take and how much will the 2 ohm resistor take. So first I'm going to use the formula V total is equals to IR total to find the current. And the current I'm getting is 2 amps. So 12 divided by 6. 2 plus 4 is 6. And then I do 4 times 2. So V is equals to IR, and I get 8 volts. So this takes 8 volts. And our 2 ohm resistor will take 4 volts. I can do the calculation as well. 2 times 2 is equals to 4 volts. Okay, that means the potential difference across these 2 points, across this, should be 4 volts. So the potential difference, So the potential difference across this resistor should be 4 volts, and the potential difference across this resistor should also be 4 volts. That's going to help us a lot out to find the answer at the end. So 4 volts, 4 volts. Now what I can do is I can bring my focus right over here. Okay, And what I can do, I can find the current here. So I know V is equals to IR. So 4 divided by 6 is equals to I. So 4 divided by 6 is going to be I as 0.667 amps. Okay. You can find the current for this as well. Why not if you want to. So we have this current value over here. Now it's saying calculate the number of electrons passing X every second. So we can say 0.667 amps is equals to charge, okay, the charge and time, change in charge and the change in time, okay. And we can say time is equals to 1 second because they want the number of electrons passing through each second. So we can take T as 1, and then we look at 0.667 amps is equals to Q divided by 1. So we get 0.667 coulomb is equals to Q. Okay, we're clear till here? Now, if you already did not know, Q is equals to NE, where N is a whole number integer and Q is the charge on an electron. So I can say 0.667 is equals to N, and the charge on an electron is 1.6 times 10 to the raised power of minus 19. Using this N here represents the number of electrons. So you're just going to do the calculation then, and you're going to get 4.167 times 10 to the raised power of 18 electrons. So that's going to be the answer. So it was a bit of a tricky question, but you just need to make sure you're well versed with these type of questions and the equations, and you should be good to go. Let me just write the final answer. So we'll round it to 4.2 times 10 to the power of 18 electrons. We also shouldn't forget per second. Okay, that's the answer. All right, so that's that. Now let's move on to the next part, which is give me 1 second. So we have the next question. It says another resistor Y is added to the circuit as shown, and the student wrote the statement. When resistor Y is added, the resistance of the parallel section increases. The resistance of the whole circuit increases. So by P is equals to I square R, the power dissipated by the whole circuit also decreases. So we have to evaluate the student's statement. The problem with this formula that the student is using is that P is equals to I square R. Well, let me write 1 point first. So the first statement we're going to write is that the student is correct as the resistance of the circuit is greater. Or I think it's better to write the student is correct in saying, I think it's better to write like this, saying that the resistance of the circuit is greater. Yeah, I think that's better. So the student's first point is correct, that the resistance of the resistance in parallel will be more. So the resistance in parallel is more, so the resistance of the circuit is also greater. So that's correct. The first statement is correct. But that doesn't mean everything is correct. The first statement is correct. But the problem we run into is when we use this equation, our resistance is decreasing, so the current will also change, right? So the current is also changing, and it's going to be a bit difficult to understand what's going on here. Okay, so it's better that you use, I'll explain how we use this, how we use this equation as well, but it's a bit difficult to get around this equation. So it's better you can use P is equals to V square over R. Okay, because here what we know is that V, the voltage, will be constant. The overall voltage is going to remain 12 volts because that's the voltage of the battery. So V is same. When I'm talking about V here, I'm talking about the EMF, the overall voltage. So V is same, and then this is the total resistance. So as the total resistance increases, power should decrease. So student is wrong. Student is incorrect when he says that the power is increasing. Okay, so that's going to be your 4 marks right over there. Okay, so that's that. Now I want to talk about this equation. So why can't we use this equation? And how do we explain it using this equation? Well, first of all, the resistance, the total resistance is going to decrease. and the current across the circuit is gonna increase. Now we notice that the current is squared. So the effect of current, oh my bad, I think I took it wrong, 1 second. Give me 1 sec. The total resistance increases, the current should decrease, okay? It's the other way around. So the effect of current decreasing is going to be greater than the effect of resistance increasing. I will repeat, the effect of current decreasing is greater than the effect of resistance increasing. So the decrease effect here is more and the increase effect here is less when we compare both of them. The reason is because I is squared, okay? That is why we can say the power goes down. Now I know you will say, okay, this is correct, it makes sense, but the reason I tell you to go with this type of answer is because in exam, thinking this is a bit difficult, okay? If you can think like this in exam, well and good, use this. I will give you a thumbs up on that. But if you find that a bit difficult, I think this explanation works best. Okay, there's another one as well. You can also use P is equals to IV. We know V is going to be constant. The current across the circuit is going to go down, so power goes down as well. So you can use any of these three equations. I think the easiest one is this, second is this, and this is a bit tricky. Okay, so that's going to be your answer. I will show you the mark scheme and the examiner report as well.